Hello everyone. So today we will be starting with a topic which is called as effect of water table on the bearing capacity. Okay, so we know the equation of the bearing capacity we have already found out, which is so this is the equation. Now for applying the effect of water table, what we need to do is we have to use two extra terms, okay, which are rw and rw dash. Now what we will do is we will multiply rw with this term and rw dash with this term. Okay, so now how does these two terms work? Okay, you see here, let us take the situation of a footing. Now this is the depth of the footing and this is the width. Now if the water table, okay, if the water table is located within this region, if the water table is located within this region, okay, now this distance will be called as dw. Okay, dw. Now you have to keep in mind what is dw. Okay, from the top surface the depth of the water table we take as dw. Now again let us consider a depth equal to the width of the footing. Okay, depth we have considered from the base of the footing, we have considered a depth which is equal to the width of the footing. Now if the water table suppose drops down and now it is dropping from this side, okay, and it is reaching somewhere here within this region, it is somewhere here, then what we will do is if the water table is has dropped below the base of the footing, okay, it is somewhere here anywhere, then this distance would be called as dw dash. Okay, so two things you need to understand. These are nothing but the depth of the water, but if the water is within this region, then the depth of the water from that surface is from this surface will be called as dw, and if the water table falls below this base of the footing, then from the base whatever is the distance, that will be called as dw dash. So now rw equal to half of 1 plus dw by df, and rw dash is equal to half of 1 plus dw dash by b. So let us go to the second topic, which is called as Skempton's analysis. Okay, so this is actually done for clay soils. Which means that phi should be equal to 0, and the soil should be saturated. So this is done for saturated clay soil. Okay, now then the formula for the net ultimate bearing capacity for clay soil will be equal to Cu and C, where Cu is the undrained cohesion. And NC is a function of the shape of the footing, okay, and the ratio of df by b. Now see, in the previous case for Tarzegi, we have got that NC, NQ, and gamma were dependent upon phi, okay, but here the NC value is a function of shape of footing and the ratio df by b. You can write that down. df we already know till now, which is depth of the footing, and b is the width of the footing. Now you see this theory can be applied for any foundation, okay, for any depth, okay. In Tarzegi's theory, the depth was limited, isn't it? It was for what? Shallow foundation. But here we can go beyond shallow foundation. Okay. And the effect of shear in Tarzegi's theory was taken for the soil below the base of the footing. But here the effect of shear in Skempton's theory, the effect of shear above the base is also considered. That means in Tarzegi, the effect of shear was considered in this region. In this region, but in Skempton's, we will be considering the effect of shear here also. Okay, you can you will know this because you see in Tarzegi's theory, when you look into the diagram, the shear planes were taken till this region. That means what? The soil was, the shear of the effect of shear was only considered till this region, but in Skempton's, it will not be restricted to only this region. Okay, it will also be used like considered for this region. In Tarzegi, this region was not considered, okay, for effect of shear. Okay, that you have to always remember. This is one major difference between Skemptons and Tarzegis. In Skemptons, the effect of shear in this region is also considered. Okay. Now in Skempton's theory, there are various formulas for NC. Okay, for various types of footing like strip footing, square and circular footing, and for rectangular footing. So let us go through them one by one. For strip footing, NC equal to half of 1 plus 0.2 df by b. Sorry, not half, it is 5. 5 of 1 plus 0.2 df by b. Now, the value of NC is within 7.5. Maximum value of NC is taken as 7.5. Now, this is for strip footing. So, let us go for the square and circular footing. So, for square and circular footing, this 5 changes to 6, nothing else. And NC is less than equal to 9. Okay, so you have to memorize these formulas. So after that, let us go to the rectangular footing. So for rectangular footing, there will be two conditions actually. So if df by b is less than equal to 2.5 and if df by b is greater than 2.5. So for both of the conditions, the formula will change. Okay, so for the first condition, that means this one, the NC value will be this one. Okay, B and L, B, L are the dimensions of the rectangle. Now, if df by b is greater than 2.5, it will be 7.5 into 1 plus 0.2 b by L. So that was all about Skempton's analysis. Now let us go to the second one, which is called as Meyerhof Analysis. So in Meyerhof Analysis, the equation of bearing capacity, let us write it down. It gets modified by certain factors. Okay, just like we saw for the effect of water table, here also there will be some factors which will be multiplied. Okay, and they will be changing the equation a little bit. So let us see how it looks. So we can see here, initially the equation was what? C n c plus q n q plus half gamma b n gamma. Okay, now with this term, there are three terms which are multiplied: SC, DC, IC. Here SQ, DQ, IQ, and the third one S gamma, D gamma, I gamma, and these are called as empirical correlation factor. Now, the S value like SC, SQ, S gamma is called as shape factor. Then DC, DQ, D gamma will be called as depth factor, and IC, IQ, I gamma is called as inclination factor. Okay, now you see here the major limitation of Tarzaki's theory. You should always remember that it is used for or you can say it is applicable for shallow foundation. That is the major limitation of Tarzaki's theory. We cannot go beyond that. That means we cannot go for deep foundation using Tarzaki's theory. Okay, now that is why like um, we go for these alternatives. Okay, that is why we go for these alternatives, because it's not like every time we will deal with shallow foundation only. Okay, there will be situations where the loads will be huge and we have to go for deep foundation. So in those cases we have to go for the alternate methods, okay, instead of Tarzegi. You can also write here can be used for any depth, okay, a footing. Okay, so these Skemptons and Meyerhofs are used because we need alternatives for deep. We need some solutions for deep foundations also. Okay, now here this NC, NQ, N gamma, they are slightly different. Okay, compared to the NC, NQ, and N gamma for the Tarzeki. Okay, so let us first write it down. Okay, what will be NC? For Meyerhof, NC will be equal to NQ minus 1 cot phi. Okay, now NQ is very different. Okay, NQ is very different. Is equal to e to the power phi 10 phi and 10 square 45 plus phi by 2. And gamma equal to NQ minus 1, 10 of 1.45. Okay, now for clay soil, these are the values which we get for Meyerhof. For Tarzegi, it was 5.710. For Meyerhof, it becomes 5.1410. So that you have to be very clear. One more limitation of Tarzegi was that his theory could only be applied for concentric loading. Okay, if the load is concentrated on the center of the footing. Okay, but if the load was not concentrated on the center of the footing, then we have to take into account the eccentricity. So let us now discuss how do we tackle with the eccentricity. Okay, so suppose this is a footing. Okay, suppose this is a footing. Now let us give the dimensions. So this is the center of the footing. Okay, now suppose the load is somewhere here. Okay, at this point. So if we look into the eccentricity, okay, this will be Ex and this will be Ey. Okay, now uh, what will be the other values we can find out. Okay, now see, if this is L, this is L by 2, and if this is Ey, so this will be L by 2 minus Ey. Okay, and if this is B, this is B by 2, and if this is Ex, this is B by 2 minus Ex. So now what we will do is we'll make another footing. Okay, we'll make another footing. For suppose this is the center. Okay, now what will happen is we take this as a center. Okay, and since along this this gap is B by 2 minus Ex, okay, so we will take another distance on the left, which is a v by 2 minus ex. This center is this one. Okay, so b by 2 minus ex. On this side there is one b by 2 minus ex. Again on the left side we will take another b by 2 minus ex. Now along this there is l by 2 minus ey. So here, now again on this side we'll take another l by 2 minus ey. Okay, so finally we will take a footing whose dimensions will be L minus twice ey, b minus twice x, with this point being at this point, okay, being at the center. Okay, so the new area will be this one. Okay, we can find out the ultimate load now. Okay, so if the new area we have got, the ultimate load will be if A dash is the new area, suppose. Okay, so if this is QU, the value that we have obtained, okay, that into this area will get the ultimate load. Okay, QU, if you get the ultimate bearing capacity, into A will get the ultimate load. So this is how we tackle the problem when there is eccentricity. Okay, I'm just repeating it. Please remember, if this is the center, first the eccentricity values we get ey, ex. Then if this is the width, this is half of the width, then this is b by 2 minus ex. And if this is the length, if this is half of the length, then this will be l by 2 minus ey. So then what we'll take this as the center, like this one. And if along this there is this l by 2 minus ey, so l by 2 minus ey, again we'll take another l by 2 minus ey opposite. Then from the center on the right there is b by 2 minus ex. Again we'll take b by 2 minus ex on the opposite. So like this. So ultimately we'll get a rectangle with C as the center, which is this one. So we'll take this area. Okay, then you multiply with the QU value, we'll get the ultimate load. So that is all for today. And in the next class we will be discussing Hansen's theory, physics theory, and IS code method. Okay, thank you very much.